Good day, everyone. Thank you again for visiting our online channels and attending our online educational sessions covering BEXEL Manager workflows in cloud-based environment. This is the last session of online webinars for September, demonstrating the latest workflows and features of BEXEL Manager in synergy with cloud-based solutions. And my name is Mileta Pejovic. I'm one of the product specialists at BEXEL Consulting, and today I will guide you through our latest features. I hope that you've been following our webinars in the previous 3 weeks and that you're familiar at least with common functionalities of BEXEL Manager. In the past few weeks, we explained how new features integrated with cloud-based solutions can help you to review and to share your projects using our online model viewer, how to export results of your analysis into interactive Power BI reports or Portfolio Manager, and how these can improve your workflows and increase your efficiency and collaboration between stakeholders on a project. As mentioned before, we are also trying to automate all these processes and enable seamless information and knowledge exchange. Part of this information exchange process is possibility to exchange scheduling methodologies and templates to create construction schedules. Another aspect is possibility to share look-ahead plans and federated BIM projects using our online model viewer. The next one is use of various reporting options to manage and confirm progress entries, to exchange schedule and cost analysis using Power BI integration, and ability to perform advanced multi-project and multi-version analysis using our online Portfolio Manager. As in previous sessions, today we will guide you through the entire process of creating construction schedule, optimizing it and generating customized look-ahead plans in BEXEL Manager, and also we will demonstrate the process of collaboration between office and on-site team and making progress entries. The last part will be workflow to compare planned and actual data, and finally how to report important and key performance indicators to other participants using our cloud-based solutions and Power BI reports. The topic for today is in a way sequel to our previous session, and in the first part we will demonstrate workflow to create construction schedule and 5D BIM simulation, and once the schedule is generated, the schedule will be also analyzed and optimized, and in the second part we will demonstrate the process of progress monitoring using BEXEL Manager in synergy with online cloud-based solutions. As you already know, during the session you can send us your comments or feedback and question in our chat session, and my colleagues will be available and give you live response on all streaming platforms that you are currently using to watch us. So for all of you watching us for the first time, we are BEXEL Consulting, software development and consulting company specialized for BIM in construction. We have more than 17 years of software development experience and more than 12 years of experience managing construction projects around the world. And our company is awarded multinational member of Building Smart International. And this year we are also finalists in the technology implementation category of their annual competition. Our BIM platform is being used in almost 70 countries around the globe, and even though our software is localized in more than 10 languages, we have even more new localization in development, and our consulting services are also used on a global level, and this is just a part of our clients using our consulting services or our products. Before we start, I would suggest you to visit our webpage and introduce yourself with the latest news. This is also the place where you can request for a free trial licenses of BEXEL Manager or trial licenses for our cloud-based solutions such as Online Viewer or Portfolio Manager. If you already are using BEXEL Manager and you would like to follow today's workflow, I would suggest you to go to our user area and download and install latest add-ins, and also download free advanced sample model so you can rework or retry to do it by yourself. So now I would like to hand over to my colleague Alexander for the first part of our workflows related to scheduling.
Thank you, Mileta, for introduction. So Right now we are continuing where we left in the last session. So we have integrated 5D model with integrated cost data, and now we want to add time dimension or 4D, and we want to create scheduling. For this, we again have two approaches, pretty similar in the way it is done with the cost information. So we have ability to import schedule from the outside source, from MS Project, from Primavera, and to link that schedule directly to the model elements using rules or using just a manual linking of the model elements selection sets or by some properties. Or we have again automated intelligent scheduling process that will allow us to create schedule, to generate basically schedule automatically using what we call zones and methodologies. We will today go through this process and we will show how the schedules could be created using this process. Of course, this created schedule then could be used as a planned schedule. It could be copied to actual schedule where you're gonna enter the progress, which will be shown by my colleague later. And again, these schedules could be exported into Power BI reports, integrated dashboards, Oracle, Primavera, or MS Project files. And of course, we can create automated 4D, 5D simulation, and the product is basically integrated 4D, 5D model that could be further used for progress tracking or other activities on the project. We will just briefly go through the process of creation. So how the intelligent scheduling process works. It uses the information that is in the model to generate schedule logic. So if you think about scheduling in general, it is comprised of two main processes of spatial project organization or spatial work distribution and functional or methodological work sequence definition. So what this means, spatial project organization means that you're always organizing your works on the construction site regarding the spatial structure of your model. So if you have multiple buildings, you're going to divide your schedule by buildings. If you have multiple stories on every of these buildings, you're going to define the subtasks for the stories. If you have multiple zones on one story, you're going to define these zones or phases as well. So this is one part of the schedule organization. Another one is work sequence, where you define that, for example, you first go with the site preparation, then you go with the excavation. After the excavation, you're going to execute foundations and so on and so forth. So this is something that you, with your intuition and engineering knowledge, are doing every single time when creating schedule. And you're doing it for every building, for every floor, for every zone. So our main idea is simple. We just want to automate this process. We want you to define the work sequence once and to define spatial sequence once, and then to have intelligent algorithm that creates the schedule itself. And not only that, that also allow you to transfer this knowledge, these methodologies to the future projects. So how the whole system works, as I said, user is defining spatial distribution of works using zones. User is defining functional distribution of works using methodologies. And these logic matrices are then combined and schedule is automatically generated. So let's go to the process itself. After successful integration of cost information into BIM model, the next step is to integrate time dimension or to develop a schedule. In today's session, we will go through the process of intelligent scheduling creation. That means that we're going to generate schedule automatically using zones and methodologies in BEXEL Manager. So as we explained in introduction to this module of today's education, we have two levels of schedule organization: spatial works distribution and methodology or functional works distribution. For the spatial works distribution, we're gonna use the information that is available in BEXEL Manager. That means that in this case, we're gonna actually define relationships between, first of all, buildings, and in this case we have Tower 1, Tower 2, building base and foundation pit as a specific spatial zones of the project. After that, on the next level, we will specify the phases, where building base is subdivided to 6 distinctive phases of the project. And on the last level of spatial distribution of works, we will distribute works on the vertical axis by floors. So all of this information is already available in BEXEL Manager, like the floors. So that is the information that is inherited from authoring tool. The phases and buildings could be modified and manually defined in the form of selection sets, or in a form of additional property that could be manually or automatically populated in the authoring tool or later in BEXEL Manager. So the first step is to go to the schedule, zone editor, and to create first zone for buildings. So how we're gonna do it? We're gonna just simply link, in this case, selection sets that are defining different buildings of our project. And here we have ability to first of all select all the parts of the building at once, and to define create relationships option. I can click OK, and here we got some basic connection between different parts of the building. We can reorganize this sequence to be more logical. So we're gonna go with foundation pit, building base, and then we can specify, let's say that tower 1 and tower 2 are gonna be executed in the same time and after the building base. What we can also do, we can specify this finish start relationship to be of copy to children type. That means that the works will continue after certain group of work is completed on the building base. That same group of work could be already continued on the tower 1 and tower 2. So we will not wait, for instance, for the whole works to be completed on the building base and then to start towers. It would be impractical, for instance, to wait until the building base is completed with all the interiors, with the facade and everything, and then start concrete works on the towers. We want to continue as soon as we complete construction on the building base. We'll just continue building the towers and following with the finishing and MEP works in the building base to save time. So the first zone is buildings, second zone is phases, and here we will just have, again, very simple sequence between phases, create relationship. We're gonna just a little bit reorganize this sequence, auto range it, and the last one will be stories. And this one is pretty straightforward. We'll just go to the building stories and we're gonna select all the stories, create relations automatically, and here we're gonna just check the sequence. As in previous cases, it seems like everything is as it should be from the lowest floor to the highest one. So we have specified the spatial distribution of works on our project. The next step is to specify functional distribution of works on our project, and for this we're gonna refer to cost database. So how it is done? We have to go to the methodology editor module, and we're gonna create new methodology, demo methodology. For the purpose of demonstration, we're gonna show just a few steps, let's say how we're gonna assemble methodology for the structural works, for the basic structural works, and later we're gonna use complete uniform based methodology, since it would take too much time to just show it in a such short time that we have available for this webinar. So the whole process goes pretty similar like with the zoning. So you go with the new item, a linked item, specify the cost classification that you're referring to, and then we're gonna insert some of the important cost items. So first we're gonna need site grading and excavation as the first group of works that should be executed. Then we would need also site shoring to be executed, so we can in the same time import both of these. We call them methodology items, and we can define finish start relationships between them. So the next group of work is foundations, and then we're going to simply go to the substructure foundations. We have two types of foundations. We have piles and footings and pile caps. So we're going to add both groups of foundation works. We're going to probably start with the pile foundations, and after that with the footings and pile caps after that is complete. After we have completed our foundations, the next step is for certain core bearing walls and bearing walls, as well as upper floor framing elements. So in this case, we're gonna go to the section B. We're gonna find the core walls. So first we will go with the core walls, then we're gonna go with the bearing walls and upper framing structure. That means beams and slabs. So we're gonna just enter those three methodology items, go with the core walls first, then bearing walls, and then with the upper floor framing horizontal elements. So this would be our methodology sequence, and here we have a few things to modify. So first of all, first four groups of works are the works that are generally finish start relationship works, because you need to first complete site grading and excavation to start with the site shoring. After the site shoring only you are able to start with the pile foundations, and of course when the pile foundations are complete, then you can start with the footings and pile caps. But when it comes to the core walls, when it comes to upper framing, and when it comes to the load bearing walls, we can for sure specify, since these works are not limited to only one level like foundations, these works are going to repeat throughout the building of all 22 floors. We don't want to wait until in the whole building this group of work is executed to start with the next group of work. So we're gonna define that these works are gonna be copied to children relationships. What that means? That means that in this case, when you complete core walls and bearing walls in a certain level, you should start with the upper floor framing structure on the level above. And to ensure that upper floor framing or the slabs and beams are not gonna start before the support structure on the level below is completed, we're gonna just create what we call backward relationships or constructive relationships and define constructive offset. In this case, we're gonna be sure that this group of works is only executed after the supporting elements for them on the lower floor are executed. As I said, this is just a small part of the methodology that we executed in a few minutes, just to show you how the whole process is envisioned. And we're gonna of course use a complete methodology for all groups of works like this one here. So it is not much more complicated than what we have shown. After the structural works are completed, then we would just have to complete the sequence with all the following works, just defining the logic of project execution. And of course we also have ability to do a next level. So in this case we have ability to define, let's say, sub activities on certain activities, like say core bearing walls. We can just define reinforcement, formworks, concrete pouring and concrete finishing on the next level of this methodology. So right now we have methodology and we have our zones, and the next step is to create what we call creation template. So to assemble creation template, we're going to just simply create a new template. Let's call it uniformat 2 levels template, and here we're going to just combine the rules that we have previously defined. So first of all, we're going to go to methodology levels, and we're going to use uniformat methodology, the first level of uniformat methodology that was specified more or less in the pretty same manner as the demo methodology that we have shown today. Then on the second level, we're going to use just the second level of the same methodology. So you remember these subtasks for reinforcement, former, concrete pouring, and concrete finishing for certain concrete works. Then on the next level, we're going to use building stories. So we're going to use zone items, which are building stories. And on the last level, we're going to use phases. So for every floor, whenever it's required, for instance in the building base, which is like 6 times bigger than the area of a single story on the towers, we're gonna divide this big area to 6 separate zones in order to optimize use of resources on our project, so that we can actually execute this big area in 6 separate phases using the same resources that could be later used in the area of towers when we start. So we're gonna use this one, and of course since we also have a building level, we can also introduce an additional zone that we have created, buildings, and in this case we're gonna place it before all the other zones. So on the first level, we're gonna organize schedule by buildings. On the second and third level, we're gonna use first and second level of methodology, then stories, and at the end phases. We're gonna just click OK, and right now we have everything prepared for our schedule creation. So right now we're gonna just go to the schedule editor. So after we have done our homework and we have created zones, methodologies, and creation template, generating the schedule is a very easy and a quick task. First of all, we're gonna just create new empty schedule. Let's call it uniformat 2 levels schedule. We're gonna confirm which cost classification or which cost version we're gonna use. We're gonna use the one that is organized by cost classification structure, and click OK. Okay, right now we have our basic schedule, which only contains one empty task. So in order to create complete schedule that is linked to the model, we just have to start creation wizard, and we just have to load the template that we have just prepared a few minutes ago. So we're going to just click OK and click OK to generate the schedule. It will take again 10 to 15 seconds, depends on the scale of the model. And here we are. Here we have a complete schedule created out of methodology and zones without manual creation of segregated tasks, without manual creation of relationships, or without any specific linking of model elements with the tasks of the schedule. So if we expand all, we're going to see how big this schedule is, and you can see here that we have 2,500 tasks, that we have 4, almost 5,000 relationships, 6 levels of the schedule, and we are able to see how big this schedule is. So it would be probably more accurate to call this schedule structure, since when we are creating the schedule, all the durations of the tasks are equal and they're set in the settings to the default value of 40 working hours. This could be easily changed as well. And of course, the next step would be to optimize the schedule duration to optimize all the parameters of schedule. We're going to today just a little bit explore what of the analytics is available within the schedule, the optimization process, and progress tracking that comes after this process will be explained more in detail in the second part of this session. So we can pop out the window so that we can have better view on our schedule. As I said, since we were using the logic of location-based scheduling, we have now tried to create the steps or to create the schedule levels in such a way to try to have more or less equally sized working area or working front that we can attack with the same amount of resources, so to have very streamlined process. We can switch from Gantt chart to line of balance view and check how it looks like. So as I said, this algorithm is set up in a way to try to optimize in the best possible way the process to keep all the tasks as continuous as possible. So after this we just have to go and to check first of all some basic task reports. So here, as you can see, we can see what is a cash flow, we can see what is a cumulative cost, S-curve, we can check the status, let's say, of the materials, in this case material use. Of course, right now it is not a completely optimal solution, which is understandable since we have just created schedule structure with the equal duration of every task, so we need some fine-tuning in order to achieve more optimal resources planning, more optimal durations, more optimal time frame, more optimal cash flow, and so on. So we can go and check all of these values and actually to assess our schedule. Of course, this doesn't give you a full picture because we have more or less 2 or 3 different parts of buildings. Maybe it would be probably more accurate if we go one by one and check on that level the cash flow. Then we can see that it's closer to the optimal one, you know, because you cannot just expect that you have ideal S-curve if you are at the same time building 2 towers and a huge building base with a big underground parking lot. So it is probably more accurate to go and to check every of these parts of the project for the cash flow and cumulative cost and material distribution, labor distribution, and so on. These fine-tuning steps, there are few very interesting automatic tools that you can use for optimizing your schedule, and this will be explained in the second part of the session by my colleague. So that would be it when it comes to the intelligent scheduling workflow. As we said at the beginning, we have started with the 5D integrated model, and through the use of zones and methodologies we have created schedule or schedule structure that is ready for the optimization and progress tracking process.
Thanks, Alexander. It was very clear and concise demonstration. And if our attendees are interested in more detailed explanation of scheduling options and settings, I would recommend you to watch one of our previous webinars completely dedicated to that topic. My colleagues will leave you the links to that webinar in our comments. In the second part of this session, we will focus on progress tracking and reporting. But before that, I just want to show you how this instantly generated schedule can be easily optimized using our intelligent tools. So as you already know, initial task duration for auto-generated schedule can be set in settings, and by default this is 40 working hours or a typical working week. But selecting tasks, we can manually change their duration, or by selecting multiple tasks, we can edit the duration using Task Editor. However, BEXEL Manager offers you more advanced options for schedule optimization, taking into consideration daily outputs or resource availability. So I will pop the schedule up so we can have a better view on entire screen. So entire schedule is already created using location-based planning, since On this demo project, we tried to create construction zones in a way to each zone contain almost equal working areas, and they can be executed with the equally distributed resources. In a line of balance, you may see that our scheduling algorithm created initial schedule already trying to distribute activities as continuously as possible. But if we want to optimize task duration according to available resources or according to actual quantities of different activities and productivity rate of our workforce, the fastest way is to do it by changing task duration based on daily outputs. And last week, Alexander showed you how you can create cost classification and cost items. And for each cost item, you can specify daily output or what is the amount of works that your team can execute daily. If cost classification contain cost items with accurately specified daily outputs, then we can rely on to this information and go back to our schedule and find tasks for which we want to apply task duration based on these daily outputs. It's always a good practice to have a baseline schedule as a backup, so I will duplicate this auto-generated schedule and apply optimization on that one. So later on we can compare previously saved schedule as a baseline with this new one optimized version. I will pop it up so we can see it on entire screen. And we can execute optimization for just one or for multiple selected tasks or even for entire schedule by selecting all leave tasks and then using option update task duration. And there we have two options: update task duration by daily output sum or daily output max. Our engine will identify all selected tasks and all activities related to each of them. Since all activities are generated from cost items specified in schedule methodology and all cost items are already linked to respective model elements in cost version, the system can calculate what is the quantity of works for each activity in each task. And now, since it has information for daily output of each activity and quantity of each activity as well, it can calculate what is the expected duration of each activity as well. The only question is to tell the system which calculation method to use in case we have multiple activities in one task. Whether we want to apply summarized duration of all activities divided to respective daily outputs, or we want to apply duration of the largest or longest activity divided by respective daily output. The preferred option if you want to preserve tact or pace of your activities is the second one. So after completion, you immediately see that total duration of our schedule is significantly decreased. And if you look at the line of balance, you see that activities are extended or shrinked based on required quantities and specified capacities of our resources within daily outputs. If we check our task report charts, cash flow and S-curve are now more optimized, and even these activities and resources are more equalized. So labor as well. Now we don't have any high peaks, so we don't need to use more advanced tool for resource optimization. Since we don't have time now, I just want to mention that if you need more advanced tools for optimizing resource allocation, we have a resource leveling option where you can optimize your task and activities even further by specifying available resources, and our algorithm will recalculate task duration based on necessary resource allocation and available resource that you specified. This will be explained in some of our next webinar series. Now I want to show you another already more optimized schedule that I've created previously, and if we compare this one with originally created one without any optimization used, You can see that the total time is even more reduced now for almost 2 years, while line of balance is now even more improved. Look at how all architectural and MEP works are set to be executed as late as possible, while construction works are being executed in 3 passes by each level. Firstly core, then main construction, and lastly staircases as soon as possible. So architectural and MEP works are set in their own pace and will be executed in a way that by the end their finishing date is closing to finish date of construction works, with around maybe month and a half or 2 months difference that actually represent a small buffer or spare time in case that some structural works are in delay or similar, in case the construction works are going as planned, or if we are optimistic, we can easily reschedule and shift all these architectural and MEP works to start a few weeks ahead. And also if we check task report for example, building 1, activities and resources are even more equalized, and S-curve and cash flow are even more improved. So for this session, I will use this schedule to show you the workflow for progress monitoring using our system. So I don't want to export Excel files now. Since all data is connected, we may easily export this into various customizable reports, Excel files, or Power BI reports. The entire idea of progress monitoring in the integrated platform is to streamline and automate processes and to help all participants in the project to collaborate and exchange information seamlessly between office and site. And of course, ability to report all relevant data to executives. So once we have construction simulation, we can review this simulation in the application using schedule view. This is execution of how our current optimized baseline schedule look like. And this simulation can be shared as exported videos, images, or through our online viewer animation. The first step in progress monitoring process is to prepare look-ahead plans for a specific construction period and provide it to our site team. So using schedule animation settings, we can set animation period on a daily, weekly, monthly, or any custom period by changing these settings. For this exercise, I will set period to be fortnightly, or each frame will represent period of 2 weeks. So when we play this simulation, we can only see works executed by the end of every 2 weeks. This could be useful if our reporting or certification period is every 2 weeks. So you can see how this animation looks like. Every frame is period of 2 weeks. But what is typical situation is that reporting and certification of progress is usually done on a monthly period, and if we change this period to be every month, here we can also change it to not just be every month, but instead of that every 2 or any custom number of months. But for this exercise I will just leave it to be 1 month, and then since the period is set to 1 month, we can play it or use animation and presented tasks in display to select all elements that should be completed. Select first all leaf tasks and then all elements and activities that are completed, and add all elements that should only start in this period. And we can save these selected elements as a selection set. For example, look ahead for the first month. So now I will demonstrate the process how to create look ahead and progress entries if we already have an ongoing project and we already have created 5 or 6 monthly progress entries for executed work so far. And now we just need to create new look ahead plan for the upcoming 7 months of construction execution. So instead of manually selecting elements, as I showed you previously, I will use a script that can be executed using our API console. These scripts can also be from our user area, and using provided description within each script, I believe that you don't even need any programming knowledge to edit and use these existing scripts for your projects. This one generates selection sets of elements planned to be executed from the last progress entry date or from so-called status date. And in our case, in this specific project, the status date or last progress entry date is July 1st, 2023. And if I run it, you see the execution, but we can also use variation of this script where interval duration and interval counts can be changed for more customizable look-ahead selection sets. Another interesting and very useful script I want to show you is the one that generates multiple selection sets for entire duration of our construction period, divided into specific intervals. And commonly used intervals are daily, weekly, or monthly. And daily interval is most detailed one, and it will group all elements executed for each day, and monthly will create monthly selection set for each month of execution. So these selection sets can be later used for construction simulation in our online viewer, and I will show how this works later on. So now we can go to selection sets and see results of these scripts. The first one created selection set is for first month of look ahead planned, and in this case this is for the 7th month of our execution, and all tasks which are planned to be executed for this month are organized into selection sets by task name and activity name. Also, you can see that in the same folder I saved previously generated selection sets representing look-ahead plans for previous 6 months of execution. By selecting these selection sets, elements in view are also selected, so this can be used as some kind of history of our progress entries during time. In selection set folder called schedule animation selection sets, we can explore results of the second script. The one that we used is for monthly runs, and you may see selection sets for monthly, daily, and weekly, because previously I used the same script to generate weekly and daily selection sets, which I will show you in our online viewer. So any of these created groups can also be shared using an open BIM collaboration format or directly by uploading selection sets from our BEXEL Manager to the online viewer. Firstly, I will use BCF Manager within the BEXEL, and I just drag and drop selection sets here. As you may see, I also saved BCF issues for each previous look-ahead plan in the past 6 months, and now these can be directly shared if you have an online account, or they can be saved and shared using BCF files. At this moment, we can load these BCF files in our online viewer, but very soon we are planning to integrate and make a live connection between our online viewer and BEXEL Manager for synchronizing BCF files and selection sets directly. So now when we have entire project with look ahead selection sets saved, we can share all this information by publishing entire project to online viewer, and I will publish it using this option. And additionally, we can choose how to organize exported model sources for easier exploring in the viewer. So I will organize them by selection sets in this case. And using cloud-based online model viewer, site managers or subcontractors can easily review entire project using their mobile devices, for example, on site. And then they can use existing information that we send them and all these elements grouped and saved as a selection sets or BCF files as some kind of guideline for construction works that's supposed to be executed and approved next month. So when we go to provided web link, this is how the loaded model looks like. And additionally, you may change colors and visibility options of model elements. So these saved selection sets can be explored. And using animate option available on right mouse click, we can animate these selection sets that we previously generated for schedule animation using script for a monthly or even daily frequency. Now in Online Viewer, we can explore and orbit through the project while at the same time construction simulation is being shown and executed. We can isolate elements planned to be executed next month directly from selection sets, or these elements can also be selected and isolated by loading previously received BCF files for look-ahead plan. So I'm going to load it, open previously saved one, and when construction activities are executed, our site team can update these provided selection sets just by simply selecting actually executed elements on site, and all other elements which are not executed can be hidden. Entire process can be done even on a mobile devices such as tablets, and then the site team can save these newly created groups as a new BCF files of completed works and send it back to the project managers or office teams for revision and final certification. The process of progress entry from received information from our site team is now relatively simple, and office team can load BCF file containing these executed elements. These elements now can be visually reviewed, and it's always a good practice to save these received BCF files as a new selection sets or as a new groups. In that way, a manager creates, in a way, a history of previously executed works for each progress entry. In our case, it's a group of works executed in the 7th month of our schedule, and I will save it as an archive before making a real progress entry. Another good practice is to duplicate an existing schedule before making a new progress entry. Our software allows you to save and explore an unlimited number of schedules in one project, so you can review different options, track the history of schedule changes, or make advanced analysis of different schedule versions against each other. For entering progress information received from the site and updating the actual schedule, the easiest way is to use our intelligent progress editor window. This tool is also updated, and now this window can be independent and even moved on a second monitor if you have it. I'm trying to recreate this process and how it would look like if you have it on other screen. So at the same time, user can review the model in a view and see the progress entries. I will turn on the visibility for all executed elements in our previous 6 months, and since progress entries are related to these elements, just by selecting progress entry in this window, on the left side or activities on the right side, you are also at the same time selecting elements related to these selected tasks in our view. The 2nd month. Also, we can select elements executed during multiple progress entries, for example, in the last 3 months, and the summarized cost of these works is also visible in top row of this window. On the right side, we can switch and see tasks, activities, or classification hierarchy of all works executed in each selected progress entry. This gives us even more flexibility to accurately add and confirm executed quantities, and also to confirm cost which is spent during this period. Another new option is ability to add new columns here for progress entry. So you may specify, for example, progress entry for each subcontractor, for example, progress entry for subcontractor 1 and subcontractor 2, and then any of these information from these columns can be used to organize progress entry by just drag and dropping into the top, for example, by subcontractors. On the right side, as I mentioned, you can see each task and activity added in progress entry and information about total quantity and price, working hours spent for execution. Also, you may see information of executed quantities and remaining quantity in quantity units and in percentages. And using different grouping, you can review this information by scheduled tasks, activities, or by cost items related to activities. So now let's make a new progress entry for 7th month. First, we need to set the time frame for this entry, and this was for executed works between July and August. Once we set this time frame, our engine can already recognize all tasks and activities planned to be executed in this period. But since we have a feedback from the site team in form of selection sets of executed works, I will choose option from selection sets and load the executed month 7 elements. Another useful info here is if your selected elements are linked to some activities that are not planned for this period, the system will inform you that working hours spent for these activities during provided period will be auto-initialized. Preferred option here would be OK. Instantly from these elements, the system recognizes executed task related to these elements from selection sets, and based on quantities of these elements and specified time frame, it also calculates and populates executed quantities and cost for each task. In the same way, the percentage of completeness for each task and activity is also calculated. So now we can review and confirm added data. This process is very easy and fast and gives us more time to, let's say, additionally validate and confirm these tasks and quantities and percentages, and also to confirm if these quantities are reflecting the real picture from the site. If, for example, I am the contractor or I have an information from subcontractors, I can change this information about time spent for execution of each activity, because initially system reads a schedule calendar, settings for working hours which can be changed, and also resources used for the execution of all activities in this period can be changed. So we can override quantity or cost for these resources in total, or we can, for example, select just specific activity, such as reinforcement in this case, of footings, and change resources spent only for these tasks and activities. I will set that quantity of labor is increased, and also the quantity of spent steel is increased. So we actually had some unexpected expenses due to any reason. Changing resource quantities, the system will recalculate actual cost and all respective information, such as, for example, earned value, cost variance, cost and schedule performance index, and similar. And once the progress entry is made, we need to apply it by marking the last entry date. The status date can be manually set when you made progress entry, or just by clicking update, the status date will be set to 31st July. In this case, because the last day of the current month is that one. The system updated schedule, and I will just pop up this window so we can compare it with a baseline and analyze some of the available information now. Here we can check some key performance indicators, such as, for example, baseline and actual cost, earned value, cost variance, cost performance index, or we could add more columns here, for example, schedule performance index, which gives us real information how close the project is being completed compared to the baseline schedule. All these information are instantly updated for each task after each progress entry. So now for any selected task, we can analyze executed quantities for each activity. I will select one of these tasks, for example this one, and we can see quantities, actual and remaining cost for resources and also for the quantities of resources used for execution. And in task report, all these information are actually visualized in form of cash flow or S-curve, and we can check comparison for material, labor, and equipment. And this is just for one selected task. The same can be done for entire schedule, or for example just for one building in our case, where blue lines representing actual information and greens are baseline information. In the S-curve, the same information are available, while in the material chart, we can see filtered material just for reinforcing steel distribution for actual and baseline schedule. And one of the benefits of this integrated system is the ability to export all these previously shown information directly to Excel and share it with relevant participants on the project. There are a few other ways for information exchange, and one of them is exporting Power BI reports into customizable Power BI templates, providing all previously seen information organized in a more, let's say, interesting graphical way. Before that, I just want to show you another way to immediately make progress entries even without selection sets received from site. Again, the best workflow is the one that I presented previously, but sometimes we understand that it's difficult to obtain BIM data from the site, and in that case, you can still use assistance from our system. Firstly, we can specify name and period for executed works, and by doing that, since everything is integrated, our system already knows which are activities planned to be executed in this period, and based on elements related to them, what are quantities in this period. So here we can just use option add planned, and system shows us all tasks and activities and even number of the elements and their quantities which are planned to be executed in this period of time. And now we can change information for each column here. We can change executed quantities or percentages if we know that some tasks are executed more or less than it was planned. And also this grouping can be changed by activities or cost classification. I don't want to apply these changes, but I want to show you another way, which is third way, if you don't have elements from site and you still know which activities or tasks are executed. So instead of using the previously shown option from planned, you may choose to add progress entry from activities, and then from the list of all activities from the schedule, you can just select the ones which are executed in this time frame. Once you select tasks or activities, then you may specify their percentage of completeness or quantities as well. There's also a possibility to import progress data and actual quantities and price using our open API and connection with some external systems such as ERP or similar. And finally, when we made progress entries, we can export everything into online solution, firstly to Power BI reports with an embedded online viewer. And for this exercise, I will choose to export earned value analysis. And here I will paste the same link which we previously exported for online viewer model. From this window, I can export only the last actual schedule and the baseline schedule, and that is the suggested option. But in this case, if we want to make more advanced analysis and compare multiple schedules between each other, I would export baseline and all actuals after each monthly progress entry. An important option in this window that can highly affect the quantity of exported data and the speed of export itself is interval of exported date. The most detailed one is daily, and the system would export cost and quantity and all other data for each element for every day. And this high level of information is rarely used, so I will switch it to the typically used monthly interval, and hit OK. Additionally, you may choose if you would like to apply some color coding rules in Power BI by creating custom breakdown hierarchies. I will export all of them and then save the file. Exported Power BI dashboard template for earned value analysis is exported, and I have already refreshed the data since big project as this one, which contains 7 exported schedule version, will take 5 minutes or similar to load. And the next step, if we logged in to BEXEL Viewer, is just to publish Power BI online and then check results. You also can make the published report public if you want to share it with other participants on the project. I will now open this dashboard, and this free template is already organized in a way that everyone can easily read and understand present data. The embedded view shows the model, while on the right side we have indicated status date and all calculated key indicators such as actual cost, earned value, cost variance, and more. S-curve shows planned and actual cost and planned and earned value, and after the last entry date, actual cost line is flat since we don't have any progress for that period. On the bottom, all tasks and activities are listed with the respective information for quantity, cost, and earned values, and values for performance indicators are only changed for activities that have progress entries. In our case, mainly for substructure works, because only for that part of construction works we edit progress. In the middle, you may see how the schedule performance index and cost performance index are changed during execution, and basically we were spending more money than planned before May, while in the last 2 months our expenses are relatively fine, while at the same time we are performing slightly behind schedule, and only in the last 2 months we are improving and now are even ahead of baseline. Practically the same info is shown in the cost and schedule variance graphs. On the left side we have cash flow by months. The greatest thing is that everything is connected and interactive, so if we select cost, for example, for July, in the view all elements are executed by the end of that month, are presented, and all respective date is changed. So we can see cost items and tasks related to these elements. And by changing color coding scheme from custom breakdowns, elements will be colored according to different information, in this case by construction zones. We may select multiple months in our cash flow, and by doing that we can see all executed activities from the beginning, their key indicators, and color by zones. If we had subcontractors, for example, for breakdowns, we could easily color code these elements by different subcontractors. In the list of all items in this period, we can analyze quantities and cost, and by selecting of any cost item, respective elements are filtered in a 3D view, and these are core walls, for example, that are still not executed, and you may see only planned cost and quantity information available in the graphs. Even here, by selecting multiple months after status date, we are basically making look ahead of elements that shall be executed in selected period. Since I also selected the last progress entry month, we do have some planned and actual values visible. Since information for each element are exported, we can even select elements in a 3D view one by one for core walls, and the dashboard will change all relevant indicators for them. But since core walls are still not executed, we only have planned values. Again, we can change coloring mode and color model by uniformat codes if we need to analyze specific items in more detail. So for reviewing executed foundation works, we could select only uniformat A classification items and then select only ones that we want to analyze, for example, foundation slabs. And as I'm selecting these elements, we can see if we are actually making profit by executing these elements, and also if we are ahead or behind the schedule. So these types of reports have great value for managers and executives, and also for subcontractors as well. The next Power BI dashboard is very comprehensive, and it's mainly intended to be used by subcontractors or cost and project managers interested in very detailed analysis related to each resource used for construction. And again, in the middle of this report, we have embedded online viewer, while on its sides, we have multiple charts dedicated to different resources, materials on the left side and labor on the upper right side, while the main key performance indicators related to equipment are visible in the lower right quadrant. Each table contains listed resources of respective type, and each column we have calculated values for cost, quantities, performance index, and so on. Again, these charts are very advanced and detailed, and we can use these analyses to help subcontractors to understand their performance and optimize processes in order to eventually achieve more profit. Again, since everything is interactive, by selecting any resource item in the charts, the elements related to these activities or resources are involved and visible in the view. At the same time, all charts are being instantly changed based on information from selected element. And we may explore, for example, some executed structural elements and see these results. This progress report Power BI dashboard is still in beta version, and it will be available very soon, but I just wanted to show you potential and possible use of available data and how we can even compare baseline schedule in the left with the actual schedule in the right view. Additionally, when the final version of this template is released, I hope that we will have some more distinctive color difference between planned and executed elements. And similarly, as in previous dashboards, by selecting any chart item or cost items from the tables, instantly all information in charts are updated and related elements in a view are selected. So we can review some of executed structural works. Again, all the data for all these dashboards extracted from exported files, and it's more or less the same. The information are more or less the same, only these templates are differently organized, and this just gives you an idea how we can differently present and organize and report available information by creating different templates for these reports. The last one is also in a beta version and will be also available very soon. This is a payment certificate template that contains typical payment certificate sheet containing columns with planned or contracted quantities and cost, of course, while in the other columns, as a result of progress entries, we have information about summarized total quantities and cost for executed works until certification date. We also have a cost and quantities executed during certification period, which is usually 1 month. And we have also remaining quantities and price to complete entire construction. Since everything is again connected, for each model element we can see these information presented in the table or in a chart. If, for example, we select cost for the last certification period and for 1 month before, in the view we can see which elements are executed and certified in this period, and in the table below we only see cost items related to these elements because these are filtered, so we can check executed quantities, cost, and remaining expenses. Very useful filter in this example is filtering by subcontractors. So by selecting any of these listed subcontractors, only elements assigned or contracted with their company are visible in our view. These filters can be combined to identify and analyze works executed by specific subcontractors in specific time frame. And instantly the table would show us planned, executed, and remaining cost and quantities for these isolated activities. These filtering options can be very valuable for site supervisors and quality and quantity control. After Power BI dashboards, Another great way to publish and share all important project information is using our cloud-based portfolio manager. So I will use publish to portfolio manager tool and export current project and the latest revision of our project that representing actual project after 7 months of construction. And when the data is published, I can access to our online platform and follow this link to see results on a web browser. Initially for this project, we can see previous 7 revisions, baseline and previous 6 months with progress data. A number of 3D elements and buildings is the same all the time, but if we check planned and actual cost, we start to see differences between these revisions. We can see that planned and actual costs are being changed from the baseline to the last actual schedule, reflecting all changes caused by progress entry every month. We can also switch to earned value chart and reorganize this visual style by drag and dropping these information groups. This is now an S-curve for entire project during first 7 months of execution, and earned value is almost as planned. Another available sheet is a timetable with baseline and actual schedule duration, start and end dates, so we can analyze how duration is being changed after each progress entry. The same thing can be seen as a graph with differently colored duration for each project and schedule revision. If needed, we can also track if the schedule itself was changed in case we added or removed some activities. And in this sample model, we didn't actually really change total number of tasks, but number of tasks on a critical path is automatically being changed after each project entry. At the end, cost variance sheet gives us info how cost variance is being changed for each of these 7 schedule revisions. This example here is a report from a different project containing more than 30 revisions, so we can see some of the possible reports and analysis currently available in a portfolio manager. You may see that we can track the number of elements per category for a multiple project revisions. We could also analyze quantities of these BIM elements, for example, volume per these categories in different project revisions. You may see that in this example, elements are filtered to show more or less just structural works in a project, and we just also added doors and walls. The portfolio interface is using any web browser and is very flexible, so look of each chart can be easily adjusted using several predefined chart types. Similar analysis, but based on element area, is commonly used so we can review areas of different model entities, and in this example different areas between same model elements in initial and in the final revision. Another thing related to BIM elements is their cost estimation, so we can even review cost estimation per model elements according to different cost versions in these different project revisions. This can be very useful for cost comparisons between tendering packages or different subcontractors, for example. A great option here is the ability to compare information from multiple projects. So users can compare the total cost of different projects spread through different building elements. In this case, and there are published information from multiple projects, and since I'm an admin, I have access to multiple projects assigned to me. Also, any user with respective credentials can have access to not just different projects, but also to different information as well. When a specific project version is selected, the look of these graphs can be changed using, for example, line or stacked bar charts. We can now compare quantities of these elements in different projects or change which elements should be presented in our chart, for example, MEP elements such as ducts or pipes. And of course, since these elements are rarely have volume information, we can check their length. Since the entire platform is very flexible, you can choose and organize raw data according to your preferences, similarly as you could do in the Excel pivot tables. We could also support open information exchange process, so all the data from this platform can be instantly exported into Excel files or images. The exported file contains information captured from currently active chart. Similar analysis can be done for other 3D model-based results, such as number of clashes detected, as we showed you in our webinar 2 weeks ago. And in this example, you may track how the number of clashes was changing during different project stages and in different model revisions during all project stages. This specific one shows you the process of identifying and resolving high priority clashes in all 35 project revisions. These detected results can be changed to different clash status during the overall clash resolving process, and as already shown, any presented chart can be visually adjusted in different ways. But more importantly, the data presented here can be also rearranged and organized in different ways to create most suitable style for your report. One of the most important performance indicators in construction is earned value. So here you may see just a part of available information for earned value analysis on a currently active project. This example shows earned value, planned value, and cost variance and completion presented for each progress entry during more than 30 months of progress entries. Relevant cost information can be reviewed from the chart or from the table directly. As previously, the visual style of these charts can be changed, or we can just narrow down the range of our analysis to different revisions of project using the filtering option, and simply by selecting project revision that we want to analyze. More available information related to earned value on the project are cost performance index and schedule performance index. So using analysis related to these performance indicators, it's very easy to track the history of your project and also to anticipate and plan mitigation activities. A great option here is the possibility to compare the performance index of one project with some other or similar projects. So now user can easily analyze the cost performance index in multiple revisions of multiple projects and track efficiency of their company or their subcontractors. The same thing can be done with schedule performance indicator, where during specified period for construction progress monitoring, we may see how close to the plan these 3 different projects are being executed. From this example, all 3 schedules have small delay and notable drop of performance during the 6th month. Another great example of very useful analysis is planned versus actual comparisons. So these graphs show planned and actual cost between revisions of the same project, and the data again can be rearranged so user can track planned, actual, and total cost and earned value for entire project or for selected period and selected project revisions. Different information or KPI filters can be enabled and disabled, so we can just choose information important to current analysis. For example, just compare actual cost and earned value for a specified period. Extremely useful and informative analysis available in our portfolio manager is a set of different delay analysis extracted again from BIM project data. One of them is, for example, excusable delay analysis. So risk manager can easily identify when excusable or non-excusable delays took place and what is the length of each of these delays. So they can track the impact of these delays on total delay of the project. And again, as mentioned earlier, each analysis can be exported directly into Excel files or images if it's needed. So when delays are related to cost information, we can also have more detailed understanding of possible risks and reflection of each delay on the entire project. One of such delay analysis is total value of impacted remaining tasks, where manager can identify where each delay occurred and what was the impact of that delay on a price of remaining tasks. Another interesting analytic related to cost is showing project cost per net area calculated for each project revision. The same information also can be compared for different projects, so we can analyze what is the project cost per square meter or square foot on a different projects executed in a different locations. Again, we can change these graphs to represent available information in the best way, and we could also use different analytics, for example, to show cost calculated directly from BIM or cost calculated directly from available BIM model elements, and cost which is calculated or added from other cost items which are not related to BIM model. Because when it comes to cost estimation, even projects created with a relatively high LOD and LOI doesn't really have sufficient information, so we could fully rely on a BIM model. So usually we have some cost items which are not related to anything in the BIM model itself. We can easily check the same information from some other projects, since all raw data from all different uploaded BIM projects are stored and available to be interactively reviewed right here within the Portfolio Manager. Total cost information, for example, can be reviewed by presenting some of most important cost data, such as actual cost, earned value, cost variance, all combined with delay information. So currently we see information for the first, let's say 16 progress entries, but this can be easily changed using our KPI filters. And what makes a huge difference in using these integrated online reports collected from BIM project is the ability to always have access to the latest information and the ability to combine this data in a most suitable way for your current scope of work. I hope that this webinar and all previous ones give you enough information to understand what our application in synergy with cloud-based solution is capable of. And also, this is just the top of the iceberg, and we are already working on our cloud-based common data environment. So even though we came to an end of this series of webinars, stay tuned, because we will have more news related to our online solutions and more new educational material very soon.